You've probably felt it already. Recruiters stopped replying. And now AI is writing pull requests faster than most juniors. If you're a junior developer, this might be uncomfortable to hear, but it's real. In this video, I want to talk about something most developers are afraid to admit. The job isn't just about writing code anymore. But before you panic, I'm also going to show you what's replacing it. And honestly, it's a better path. Let me explain. Let's start with the data. Because if we're going to talk about this, we need to be honest about what's actually happening in the market. This isn't just a feeling. In many markets, junior hiring has dropped sharply over the last couple of years. The exact numbers vary by region, but the trend is clear. At the same time, companies are investing billions into AI infrastructure. We're talking about a capital rotation, not a recession. The money is still there, it's just going somewhere else. Bootcamp grads are fighting for scraps, while senior engineers are turning down offers. That gap is very real now. And it's getting wider every quarter. So why is this happening? Why are companies cutting juniors while doubling down on AI? The answer might surprise you. Let me be clear about something first. AI is genuinely impressive. Tools like GitHub Copilot and Claude can write code faster than most humans. That's not hype, that's fact. For routine tasks, boilerplate, CRUD operations, simple algorithms, AI is already better than most junior developers. It's faster, it doesn't get tired, and it's available 24/7. But here's the thing about AI. It's really good at syntax. But it struggles with context, especially in complex systems. AI predicts the next token based on patterns it's seen before. It doesn't actually understand what it's building. It doesn't know if your architecture makes sense. Let me give you a real example. Imagine you have a distributed system running across 3 cloud regions. You're using eventual consistency for performance. Now a distributed lock fails. A race condition appears between region A and region C. Your P99 latency spikes from 50 milliseconds to 3 seconds. When this happens, tools like GitHub Copilot usually struggle. They don't know your infrastructure constraints. They don't know your business requirements. A senior engineer looks at this and asks the right questions. Is the lock even necessary? Can we switch to optimistic locking? What's the actual consistency requirement here? This is where AI hits its ceiling. Not because it's stupid, but because it lacks context. It can write code, but it can't architect solutions. At least not yet. Now, I want to be fair here. AI is improving rapidly. What it can't do today, it might do in 2 years. But right now, we're in a transition period. And here's the thing, even if AI gets better at architecture, someone still needs to validate it. Someone still needs to understand if the solution makes sense for the business. So if AI is handling the coding part, what's left for humans? What should you actually be learning right now? If you want to stay relevant, you can't just translate tickets into code. You need to understand the system you're building. That's the difference. Systems thinking means understanding how components interact. How data flows. Where bottlenecks happen. Why certain trade-offs exist. It means knowing when to use a message queue versus a direct API call. When eventual consistency is acceptable. When you need strong guarantees. One common mistake juniors make is optimizing too early. They focus on performance before they even understand the problem. That's backwards. Another mistake is not understanding failure modes. What happens when the database goes down? What happens when a third-party API times out? These are the questions that matter. People are rewriting core services in Rust or Zig. Not because it's trendy, but because efficiency is becoming a real requirement. Think about it. AI models are expensive to run. Cloud bills are going through the roof. Every millisecond of latency costs real money. And honestly, efficiency is usually what pays the bills. The companies that can do more with less are the ones that survive. So what do you do now? Here's one realistic path you can follow over the next 6 months. No hype, just practical steps. Month 1, learn how memory actually works. Not at the Python level, at the C level. Understand the stack, the heap, pointers, and memory allocation. You don't need to become a C expert. But you need to understand what happens when you allocate an object. Where does it go? What frees it? Month 2, build a TCP server from scratch. Not with a framework, with raw sockets. Understand how connections work. How data is actually transmitted. When you build at this level, you start to understand why frameworks make certain decisions. You see what's actually expensive and what's cheap. Month 3, deploy something to a real VPS, not Versal. Set up a Linux server. Configure Nginx. Handle SSL certificates. Manage processes. This is where you learn what DevOps actually means. Not clicking buttons in a dashboard, but understanding the infrastructure your code runs on. Month 4, read about distributed systems. Start with the basics, CAP theorem, consensus algorithms, eventual consistency. Understand the trade-offs. You don't need to build a distributed database. But you need to understand why certain systems make certain choices. Why is Cassandra eventually consistent? Why does Postgres need strong consistency? Month 5, learn a systems language. Rust is the popular choice right now, but Go or Zig work too. The point is to think about performance. When you write Rust, the compiler forces you to think about memory. You can't just allocate and forget. This rewires how you think about code. Month 6, build something real that ties it all together. A message queue. A cache layer. Something that handles concurrency and networking. This project is your portfolio piece. When you can explain how you built a distributed cache from scratch, you're not competing with AI anymore. You're in a different category. One more thing. Don't just learn in isolation. Find a community. Join Discord servers. Contribute to open source. The best learning happens when you interact with others who are ahead of you. And don't be afraid to start small. Your first TCP server will be terrible. Your first Rust program will have 100 compiler errors. That's part of the process. The goal isn't to be perfect from day one. The goal is to build a mental model of how systems actually work. That takes time, and that's okay. Now let me be honest with you. This isn't easy. This path takes real effort. You'll feel stupid a lot. That's normal. But here's the thing, the people who walk this path are in massive demand. Companies need people who understand systems, not just syntax. So to summarize, the junior role is changing. The learn to code in 3 months path is closing. But a better path is opening. The engineers who understand systems, who can architect solutions, who think about efficiency, those engineers are more valuable than ever. If this resonated with you, subscribe. I'm going to be making more content about systems engineering, performance, and the skills that actually matter in 2025 and beyond. The junior role is changing. It's time to think like an engineer. Welcome to DevFlow.